Good afternoon. Yes, to everyone, a very good afternoon to this class. So I can see 147 students, 148 students in the class. Okay, so there are quite few people today, I think, have joined. Yesterday, we were having some 250 to 60 students. Okay, still joining. Anyway, good afternoon, Supraja, Yaswant. Sir, what is the use of MSD classes? That is not for you, by the way. MSD is Medico in 7 days. Okay. So just like Mahendra Singh Dhoni, greatest finisher in the world, we also want our students to finish up the match with that spirit. That's why we have the MSD program. Okay, Medico in 7 days. Yes, it is not for you. It is not for you. No. Yes, hi, Surya. Yes, Rusikesh. Good afternoon. So that is for NEET students. Yes, that is for NEET students. Those who are going to write the NEET exam after a few days, for them it is. Okay, Vabhya, hi. Yes, hi. Gayatri. Yes, ma, hi. Sir, homework problems, can you explain? Yes, I will explain that. I will explain that. So when the college will open, mostly in the next month. Today morning, was my time, I listened. Okay. Good afternoon, sense. What sense? I didn't get you. Anyway, so namaste, active, namaste. Okay. To one and all in the class present over here, once again, a very good afternoon. Okay. So guys, mostly we are going to end up the class by tomorrow, like today and tomorrow. I think we have 2 days of time. So almost we are going to end up the concept, the small concept. Okay. So now, if you remember, I have discussed two formula related to the number of moles calculation, which is given mass by molar mass. The other formula is given number of particles by Avogadro number of particles, right? These two things we have discussed in the few classes in the past, and today I told you, like, I will be discussing the last formula and then we'll go for the Y map, right? Why today we have afternoon class? Yes, to make sure that you guys are not going to feel sleepy in the afternoon class. When you come to the college, then you should not feel sleepy in the afternoon time. That's why we are having afternoon class. Sir, homework questions. Harini, yes, ma, yes, we will discuss them. We will discuss them. Sir, can you explain homework problems? Yes, for sure, I will discuss them. So, can you please remind me what was the questions, please? Sir, is there exam? Manya, yes, it will be there. It will be there. Okay. Okay, sir. Okay, Nana. Okay, so in the last class, I have discussed the number of moles calculation formula, and related to that, I have given questions, right? The very first question, what was that? Tomorrow onwards, there is no gift class. I think probably tomorrow will be the last class, but it will be intimated to you officially, okay? Chalo. The first question is 196 gram of, we had the first question, 196 gram sulfuric acid is there with us, right? For this, we have to calculate. What are the things we need to calculate? What are the things we need to calculate? 196 gram of sulfuric acid is there. Yes. Moles we have to calculate. So for this, let us calculate the number of moles. Number of moles of sulfuric acid will be equal to, we know the formula, given mass by, sulfuric acid is not an atom, it is a molecule. So given mass by gram molecular mass of the molecule. So this is equal to, given mass is 196 gram of sulfuric acid divided by, what is the gram molecular mass of sulfuric acid? Guys, 98, 98, 98. Yes, very good. It is 98. You can calculate that. We have calculated in the last class. So 98 gram per mole means 1 mole of sulfuric acid is 98 gram. So on this behalf, you can get it 2 moles. So 2 moles of sulfuric acid is there with us, right? Next, further I can say, what is the next part in this question? What else I have asked? Number of oxygen in it also. Okay, number of oxygen. So you people tell me, one H2SO4 molecule, if I take one single H2SO4 molecule, then it contains how many oxygen atoms? One single H2SO4, 4 oxygen atoms. Very good. So 4 oxygen atoms. There are 4 oxygen atoms. Now you people tell me, if one molecule contains 4, 1 mole H2SO4 will contain how much? 1 mole H2SO4 molecules will contain how much? 1 molecule, 4 atoms. 1 mole will contain 4 moles. Yes, it is 4 moles. Very good, very good. I can see the response in the chart section. 4 mole of oxygen atoms. But do we have 1 mole of H2SO4 given to us? We do not have 1 mole, rather we have 2 moles of H2SO4 sample with us. So if 1 mole is containing 4 moles of oxygen, so 2 moles of sulfuric acid will be containing how much? Just double of that. Yes, very good, very good. I can see 8 moles. Yes, it is 8 moles of oxygen atoms. It is 8 moles of oxygen atoms. You guys are really super. I hope you have done this part, right? All of you have solved this in the yes, sir, isn't it 4 molecule of O2 in 2 moles? In 2 moles, 4 molecules of O2? No, it is not 4 molecules of O2. I have asked oxygen atoms, we got oxygen atoms. If you want molecule instead of atom, if you want molecules, okay. How to go down? Okay, instead of that, let us say I want, sir, please explain again, not understood. In the ready. Okay, Nana. You see, Nana, what you have in this question? Those who didn't understand, focus over here. What I'm saying is, 196 gram of sulfuric acid is given. Number of moles of sulfuric acid is given mass by molar mass. If I yes, okay, Nana, question number 2, I will discuss that. Okay, number of mole is going to be given mass by molar mass. By that way we got 2 moles. So we know that one single molecule of H2SO4, here we have 4 oxygen atoms. So 4 oxygen atoms are there. On that behalf, I can further say, if one single molecule contains 4 oxygen atoms, means 4 times more, so 1 mole will contain 4 moles of oxygen. Just the same way, 4 moles, 4 times more. Now 1 mole contains 4 mole, then 2 mole will contain 8 mole. This is the simple unitary method calculation, right? Yes, understood. Very good, Nana. Very good. Chalo. Now talking about the next question, the second question. What is the second question we had? The second question is 12 gram of C12 is there. How many moles are there? Okay. Manya. Okay, ma. You see. So we have 12 gram of carbon 12 isotope. In this, what we are going to calculate is, did we prefer NCERT of good score in it? Yes, definitely. NCERT is the dictionary for you people. Just like dictionary, English dictionary is going to make your vocabulary strong, the same way NCERT is everything for you people, remember, right? So 12 gram of carbon is there. We will calculate number of moles of carbon atom, that is given mass by molar mass, given mass by gram atomic mass, or you can say given mass by molar mass. Molar mass means mass of 1 mole of particle. So given mass is 12 gram divided by molar mass is also 12, if you remember, so it is 1 mole, right? So we have 1 mole of carbon atom. Nana, yes, what is your doubt? Please ask. It is not yesterday's sums. I have given these 3 questions for homework, right? Pujita Amma, I am discussing them. Number of proton, electron, neutron in it. Okay. So let us calculate the second part in this. Number of proton number of electron, number of neutrons. How many are present? We are going to calculate. So you people see here. What I can say is, for one single carbon atom, what are the things present? We have the nucleus, and around the nucleus the orbits will be there according to Bohr's model. And here inside the nucleus, what are the particles we will have? Inside the nucleus we have 6 protons, because we know that carbon atomic number is 6, mass is 12. On that behalf, I can say that for carbon atom 6 protons will be there, and mass is 12. That means how many neutrons will be there? 6 neutrons as well we will have. Okay, and anyway we know that proton and electron count will be same, right? So we have 6 protons, 6 electrons, 6 neutron in one single carbon atom. This is a one single carbon atom. In one carbon atom there are 6 protons, 6 electrons, 6 neutron. Okay, so you're asking what is the syllabus for the next exam? The syllabus for next exam will be everything related to number of moles calculation. What is atomic mass, molecular mass, related topics, and number of moles calculation. Okay, chalo. Now you tell me, if one single carbon atom contains these many particles, 1 mole of carbon we have 1 mole of carbon, then how many particles are going to be there? We are going to calculate now. So one carbon atom, I am doing again the unitary method. One carbon atom is containing 6 proton, 6 electron, 6 neutron. Then if I have 1 mole of carbon, if I have 1 mole of carbon atoms, then what I will have? 1 contains 6, 6, 6. So 1 mole will contain 6 mole of this, 6 mole of this, and 6 mole of this. So 6 mole of protons, 6 mole of electrons, and 6 mole of neutrons. Is it clear, guys? This type of questions will come in Sunday's test. Yes, this type of questions will be asked in Sunday's test. Okay. Next question was total mass of protons, neutrons, and protons in carbon atom. Yes, total mass of protons in grams, right? Chalo. So we will calculate now the total mass of carbon in grams. But before that, you ensure that you understood this part. If yes, please give a thumbs up so that we'll go to the third part of the second question. Yes, Manya. How to find? Yes, sir. Yes, sir. Yes, sir. Okay, Dikshita, can you please repeat second part again? Okay, Avyakt, you see here what is the question in the second part. In the second part, they're asking number of proton, number of electron, and number of neutrons, right? We know that in a single carbon atom, what we will have? Nucleus will be there that contains protons, and nucleus will contain proton and neutron. Okay, anyway, 6 protons, 6 neutron, and outside we will have 2 electrons here. In the K cell, L cell, we will have 4 electrons like this. So total how many electrons are there? 6 electrons, because number of proton and number of electron will be same. So one single carbon atom contains these many particles. If one carbon contains these many particles, 1 mole will contain how much? These many moles, right? 1 carbon, 6 proton. 1 mole carbon, 6 mole proton. Avyukt, is it understood, Nana? Please let me know in the chat section. Yes, yes, yes. Yeah, very good, very good, very good. Chalo. Okay, very good. So now proceeding further to the next part. The third part is mass of protons in it. So we have how many protons now? Just now we got 6 moles of proton with us. If we have 6 moles of proton, what is the mass of this? How much is going to be the mass of this, right? For 6 moles of proton, what is the mass of this? So let us calculate now. We know that mass of 1 proton. What is the mass of 1 proton in grams? Can you tell me? Mass of 1 proton in grams. My question is mass of 1 single proton in grams. What is the mass? Please do respond. Mass of 1 proton. My 3. 9.1, 1.67. Yes, mass of one proton in gram is just equal to 1 AMU itself. Roughly we can say mass of one proton and mass of one neutron is almost equal, and that is equal to 1 AMU. On that behalf, mass of one proton is almost equal to 1 AMU, and 1 AMU means how much? 1 by 6 into 10 to the power of minus 23 gram. Right? 1 by 6 into 10 to minus 23 gram. Now, if one proton is having this much of mass, how many protons we have? 6 moles of proton. One proton this gram. 1 mole proton will be how much now? 1 mole proton will be this into 1 mole. So 1 by 6 into 10 to the power of minus 23 into 1 mole will contain Avogadro's number, right? Na. This much of gram. Is it clear? Now on this behalf, what is Avogadro's number? Avogadro's number is nothing but of 6 into 10 to the power of 23 for rough calculation. And if you cancel this, 6 cancel, 10 to minus 23, 10 to plus 23 cancel, it is 1 gram. Right? If 1 mole of proton is 1 gram, then we have 6 moles of proton with us. So 6 moles of proton will be how much now? 6 gram. 1 mole proton 1 gram, 6 mole proton 6 gram. Right? Now, without doing all these things, yes, 6.02 anyway, without doing all these things, we can simply say 1.67 10 to minus 27. No. So this now that is 1.67 10 to minus 27 kg, but we have answered in terms of grams. Okay, we have answered in terms of grams. Now my point is, in the carbon atom, we have 1 mole of carbon atoms. In that we have the mass of proton is 6 gram. And what is the mass of neutron then? Danis, please explain once again. Okay, Nana. Danis, you see here, we had 6 moles of proton. We know that mass of a single proton is 1 AMU. Right? One single proton and one neutron mass is same, which is 1 AMU. And 1 AMU means this much of gram. If you remember, I have discussed earlier as well. Right? If one proton is this much gram, 1 mole proton will be, 1 mole means what? Mole will contain Avogadro number of particles. I have just multiplied with 1 mole. Here mole, that side also mole I have taken. Okay, so both side mole I have taken, and 1 mole is how much? 6 into 10 to 23 for a rough calculation. So if you cancel everything, you are getting 1 gram only. So 1 mole is 1 gram, 6 mole will be how much? It is 6 gram, right? Very good. Now talking about for neutron, what is the mass? Total mass of carbon sample I have given 12 gram, out of which 6 gram is proton. So neutron will also be the same, 6 gram. So 6 gram proton, 6 gram of neutron will be there. Then what is the mass of electron? What is the mass of electron? Yes, we have approximated everything. We have taken the approximated values, okay? Don't go for exactness. We have just taken the approximated values. Mass of electron will be how much? Yes, Ranjit, absolutely correct. Why did you retract message retracted? Nana Ranjit, yes. What is the mass of electron in 12 gram of carbon? The mass will be kind of negligible, okay? We should not say 0. Supraja, your answer is okay, but don't say 0. It is negligible simply. Means it is very less, so that we are not considering that, okay? Chalo. Next question number 3, 6.02 10 to 20 atoms of oxygen is their mass we have to find. Chalo, very good. I hope everyone understood this part. If yes, then give a thumbs up, and then we'll go to the next question. Yes. Okay, super. I hope no one is having any doubt. Chalo, very good, clear. So going to the next question, the third question, we had the question 6.02 into 10 to the power of 20 oxygen atoms are there with us. We have to find the mass of this sample. For this sample, what is going to be the mass? Right? So it is very easy. Supraja, no, I didn't get you, ma. What you are talking about? Supraja, is there any doubt? No, sir. Okay, ma. Okay, super. Sir, is entrance exam is based on 9th-10th basics or inter basics? Manju, definitely the competitive exam, like if you're talking about NEET especially, it will be definitely based on 11th, 12th, not on 8th, 9th basics. But to understand 11th and 12th concepts, you should have knowledge of 8th, 9th, 10th topics as well. That's why I request all of you people, whatever the 1 month time you are getting now, please cover up 8th, 9th and 10th syllabus portion. Okay, don't go for mathematics because you don't have mathematics now. Physics, chemistry and biology portion you completed. Okay, 1 mole is equal to 1 AMU into Avogadro's number, sir. Yes, Indra Reddy, you are correct. 1 mole is 1 AMU into Avogadro number. 1 mole means simply Avogadro number. You need not to multiply 1 AMU. If you multiply AMU, you will get the mass of the particle for hydrogen atom only. So simply say 1 mole is nothing but of Avogadro's number. What are the main chapter to cover? Nana, in gift program, we are only covering this mole concept part, okay, because of the time constraint. Once you come to the campus, we will be starting the mole concept chapter in full details, okay. Now you see, they are asking mass. So simply I can say, first of all, our main objective will be calculating number of moles. Yes, Y map, I will discuss Y map now. Okay, after this I will start Y map part. So number of moles of oxygen atom, because they are talking about oxygen atom, let us say number of moles of oxygen atom is equal to, they have not given the mass of oxygen, rather they have given the number of atoms of oxygen. So we know that number of moles is equal to given number of atoms or given number of molecules divided by Avogadro's number, which is equal to given number of particles 6.02 into 10 to the power of 20, right, divided by Avogadro's number is 6.02 into 10 to the power of 23. So how much we are getting here? 6.02, 6.02 cancelled, 10.20 by 10.23. So 1 by 10 to the power of 3, which I can say 10 to the power of minus 3. Here 10 to the power of plus 3. So that will go up 10 to the minus 3. So these many moles of oxygen atoms are there with us. Right now, these many moles of oxygen atoms are there with us. Sir, we should double that number for mass. No, we should not double the mass. We should not make it double for the mass. It is oxygen atom only they are asking. So when atom is concerned, we will take atomic mass. When molecule is concerned, we will take molecular mass. What is syllabus, sir? Is SSC? Which syllabus, sir, is SSC? I didn't get your point. Okay. Now you see, since we have got number of moles, now we can easily find the mass here. You people tell me, if I take 1 mole of oxygen atoms, what is the mass? 1 mole of any particle will have its gram atomic mass or gram molecular mass. If 1 mole of oxygen you are taking, single oxygen atom 16 AMU, 1 mole if you take it is 16 gram, isn't it? One single oxygen atom is 16 AMU, 1 mole of oxygen atom is 16 gram, which is gram atomic mass. Yes, 1 mole of oxygen atom has gram atomic mass, which is 16 gram. If 1 mole is 16 gram, then 10 to minus 3 mole will be how much? Sir, are you going to repeat all these things? Yes, I will be discussing all these things once again, but I request you people to please pay attention in the class now. So 10 to the power of minus 3 moles of oxygen atoms will be how much? We are just solving by unitary method, so it is very laddu question, ma. You just tell me, if 1 mole is 16 gram, 10 to minus 3 mole how much? 10 to minus 3 times of 16 gram. So 10 to the power of minus 3 times of 16 gram, which is 0.016 gram, right? Or else we can also say as this is 16 milligram. What is 1 milli? Milli means 10 to minus 3 only, right? 16, 10 to minus 3 gram is milli. So 16 milligram also we can say. Is it clear, guys? Is it clear? Sir, can you once again explain before question? Are you talking about this question or the last question? Last question was very easy, na? We had 12 grams of carbon sample. In that, what is the mass of proton and neutron I have asked. Without doing anything, I could have answered that question. 12 gram means it is gram atomic mass of carbon. So 12 gram will be 1 mole, and in 1 mole we know that number of protons and neutrons is same in the case of carbon, 6 neutron and 6 proton in one atom. So 1 mole will contain 6 mole of proton, 6 mole of neutron. Because 6 mole of proton is there, 6 mole of neutron is there, their mass is also going to be same because proton and neutron mass is same, one single proton, one single neutron. So that way we will have 6 gram of proton and 6 gram of neutron, right? Mass of 6 mole of proton question, sir. Achilles, okay Nana, you see, mass of 6 mole of proton wala question, we know one proton is 1 AMU and 1 AMU is this much. I asked you to remember this. Okay, I asked you to remember this. One proton is 1 AMU and 1 AMU is these many grams. So 1 mole of proton will be how much? If one proton is this much, 1 mole will be 1 mole. This mole part will be multiplied, and what is 1 mole? Mole means Avogadro's number. So I have replaced the mole with Avogadro's number. Hello sir, how are you? Watermelon, I'm very much fine. Thank you for asking. I hope you are also doing well. Okay, so mole I have multiplied Na. And what is Na? 6 into 10 to the 23. If you cancel this, 10 to minus 23 plus 23 cancel, 1 by 6 and 6 cancel. So we are getting 1 gram. If 1 mole is 1 gram, 6 mole will be 6 gram. Achilles, is it clear, Nana? Is it clear? Watermelon, I have not watched the movie, so I can't give you the review now. Achilles, okay sir, okay, very good, very good. Chalo. So talking about the next question, this one, please look into this and let me know whether you got it cleared or any doubt is there. Please let me know whether it is clear or not. They have given these many oxygen atoms, I'm repeating. So if these many oxygen atoms are there, number of moles we have to calculate. Every time remember if they have given mass, last question they have given 12 gram mass of carbon given. In the very first question they have given 196 gram of sulfuric acid. So whenever mass is given, we will use the formula given mass by molar mass. And then we will be getting how many moles are there. Calculating number of mole is very important. Always you have to calculate number of moles. So they have given number of particles. So we have used the formula number of mole is. We can't use given mass by molar mass here because given mass itself is not there. They are asking the mass. They have not given the mass. So for that reason, we will use given number of atoms by Avogadro number of particles. This is the formula if you remember. Okay. So on that we have given number of atoms is this much atoms given, and Avogadro number is this. So if you cancel this 10 to the 20 and 10 to the 23 here, 10 to the plus 3 will be there, and 1 by 10 to the plus 3 is 10 to the minus 3, right? Does it require to convert into milligrams? Not required. You can write in terms of gram, you can write in terms of milligram based on the question. If they are asking in grams or milligrams, based on that you can answer it. Okay. Now my point is, because we have these many moles of oxygen atom, we know that 1 mole oxygen atom is having gram atomic mass, which is 16 gram. So that way, if 10 to minus 3 mole is there, 10 to minus 3 you just multiply. 1 pen 2 rupees, 2 pen 4 rupees, 3 pen 6 rupees. That is what we have done. Can you give more examples? Yes, questions on this only we will be repeating again and again. Different varieties will be there. Just let me discuss about the Y map, then we will go to the question part. Okay, Nana, I will discuss the Y map, then we will go for more and more question like this. You will understand. Now please note it. Please make a note of it. You will understand once I discuss the Y map part. What is STP? I will discuss that only. Okay. So now let us go for the third formula. So before discussing about the third formula, I will be talking about what is that STP, whatever you have asked. Okay. Sir, is there any material for mole concept example sums? I will give you. Okay. I will give you worksheet, and I will mostly post it in the PDF form, so you can solve from there. Standard temperature and pressure. Yes. So guys, my simple point over here is, suppose that we have a balloon. Okay, I have a balloon and I'm blowing up the balloon. If you blow more air inside, then the size of the balloon will be large, right? If we are blowing the balloons, if balloons size is more, that means more gas we have inside. So what I can say, I have balloon, this is a bigger size balloon. Let us consider it is a balloon, a spherical ball inside which we have filled the gas, and this is a small size ball. Okay, so in which of these two balloons we have more amount of gas? Can you tell me? The first one, right? Yes, in the first one we have more amount of gas. So here actually one hole is there through which you have blown up the gas, and inside we have filled the gas. You say big balloon has more amount of gas, so that here volume will be more, and the second balloon the volume of the gas is less, because yes, it is correct. So bigger size balloon, more volume, smaller size balloon, less volume. The reason is you have inserted more amount of gas here inside. You have blown off for more time. So for 10 seconds, if you blow the balloon, you will get this condition. If you blow for 3 to 4 seconds, suppose you will get this balloon. So what I am saying is, more the gas you are blowing, more is the volume of the gas. And if you blow for more time, that means what? More gas, more amount of gas is also there. So out of first and second, where more amount of gas is present, can you tell me? In which case more amount of gas is present? Yes, the bigger one. Very good. So more amount means what? More number of moles. Here number of mole is also more. In the second case, number of mole is also less. So what I can say is, if number of mole is more, then the volume is also going to be more, and if number of mole is less, the volume is also going to be less, right? I hope this part is clear. If you blow for more time, more amount of gas you are putting inside, and more is the volume. So I can say that number of moles of gas and the volume, they are directly proportional to each other. More number of mole means more is the volume. And based on this, one scientist there, once again you say it, sir. Siva, Nana, Siva, it is very easy, Nana. What I am saying is, if you are blowing the balloon for long time, more time, so you are putting more gas inside. If more is the gas, more will be the volume. More gas means more is the number of moles as well. Pressure should be constant. We will talk about the pressure part once. Okay, you focus now. Number of moles and volume is directly proportional to each other. If more number of moles you are putting inside, more gas you are blowing up, more is the volume. Suppose that in both of these cases we are having the same pressure. Pressure is constant. Okay. We are maintaining the pressure constant. Let us say temperature also we are maintaining constant. Temperature also we are maintaining constant. Pressure also we are maintaining constant. Okay. Yes, we have to maintain the pressure and temperature constant. Let us say it is constant. Can you tell me what is the pressure and temperature effect on the volume and all? Simply just try to understand. In the summer season, what happens? You must have encountered this situation, like in summer season only, the bicycle tire or car tire, cycle tire, they burst. Have you ever seen this scenario? Yes, the cycle tire or bicycle tire burst usually in the summer season, because the atmospheric temperature is very high in the summer season, especially in the places like Vijayawada. The temperature is very high. When external temperature is very high, so whatever the gas is there inside the tire, that gas will be absorbing that temperature, that heat energy. So because temperature increases, that will increase the pressure inside as well. So what I mean to say, temperature can increase the pressure. Garmi se jalenge tire. Okay. So what I'm saying is, temperature can increase the pressure. Just like temperature, pressure have influence, the similar way, what are the influence of this temperature and pressure on the volume of the gas? Okay, what is the influence of volume of the gas? So simply I can say, if you want to press the balloon, then what will happen? If you are trying to press the balloon, the volume size will, the balloon size will decrease. So if you are trying to press it, You are trying to increase the pressure in the system. So if you increase the pressure in the system, its volume will tend to decrease, right? Yes, when you exert pressure on it, the balloon will burst because you are trying to increase the pressure. So volume will try to. Yes, sir, you are explaining everything so good. Thank you, Nanas. Thank you. What I'm saying is, suppose I have this kind of container in which gas is there like this. What I'm doing is, I will ask Ranjit to stand over here. Hi. Ranjit is saying hi. Okay. With flowers in his hand, Ranjit is standing up on the cylinder like this. Then what will happen to this piston? This piston will be moving down, right? Now piston will not be here. Earlier, let us say the piston was at this place. Earlier, the piston was at this place. Earlier, the piston was at this place. When Ranjit is standing on top of the piston, then the piston will be going down. Now you tell me what we have done here. Here volume was more, here volume is less. But once the piston goes down, the gas molecule will come close to each other. That means what? What will happen to the pressure? In which case pressure is more, where pressure is less? Where pressure is less, where pressure is more? 2 is more, yes, because the gas molecules are coming close, pressure is more and volume is, here pressure is less. Here gas molecules are far away from each other. So pressure is less. Lesser is the pressure, more is the volume. The similar way, more is the pressure, less is the volume. I am not playing anything with the temperature. I am not playing with the temperature, I am not changing the temperature, but what I am doing is I am just changing the volume and pressure. Piston was like this is the cylindrical system, and suppose I have asked Ranjit to stand over here. Okay, if I ask Ranjit to stand over here, then what will happen is this piston will go down and gas molecule will come close to each other. When they come close to each other, they will hit with each other to greater extent and the pressure will increase here, right? So pressure is increasing and the volume of the system, here volume was more volume was there, and here the volume is less, volume is decreasing. Volume decreases, pressure increases, inversely proportional. So my simple point is, volume and pressure, they are dependent on each other. The similar way, temperature and the volume also dependent on each other. What is the role of temperature and volume? What is the role of temperature and volume? If you try to increase the temperature, the volume of the container will also try to increase. Directly proportional, yes. Here volume and pressure, what is the relation? Volume is decreasing when you are increasing pressure. So pressure and volume, they are inversely proportional. Whereas talking about volume and temperature, on increasing the temperature, the volume will also increase. Okay, can you give any example of this? Temperature and volume directly proportional to each other. If you supply more and more temperature, more and more heat energy, then how the volume will expand? I mean, volume of the container will expand. Milk, no, I'm talking about gas sample. I'm talking about gas sample only. Railway, what are you talking about, Nana? Sir, can you explain once again? Thermal expansion of railway track. That is related to solid. The same thing we can think of this gases also. Okay, if you increase the temperature of any gas, then the volume will also increase. In the Reddy, I am talking about very simple point, like if here the volume of the container was more, if you only standing over here like this, then the piston will go down, then the volume is now very less. Here volume is more, here volume is very less. Volume is decreasing, here volume more, here volume is decreasing. But what happens to the pressure? Pressure will increase here. Okay, pressure will increase here. That is what the simple point. So volume, pressure inversely proportional, whereas temperature and volume directly proportional. Hitting a closed container containing water. Very good, Nana. Karthika, very good example. If I have a container like this, in the container I have some gas and I supply heat energy. Okay, I am supplying heat energy. Then what will happen to this container? the piston will start moving up. The piston will start moving up. Can you tell me why it is so? Can you tell me why it is so? You must have read about this in class 8th, 9th. Like upon supplying heat energy, what will happen to the temperature inside? The temperature will increase. Once the temperature increases, then what will happen? What will happen to the kinetic energy of the gas molecule inside? What will happen to the kinetic energy of the gas molecules inside? Yes, kinetic energy will also increase. Once kinetic energy increases, this gas molecule will hit the surface of the piston. Over here they will hit. Then what will happen? They're continuously hitting on the surface of the container. Then the piston will try to lift upwards so that the volume of the container increased now. So temperature increased, volume is also increasing. Is it clear? Mahima, explain. Okay, Ma, you see, what I'm saying is very simple example. I have this cylindrical system in which this piston is there. Just like while giving the injection, you must be knowing this kind of piston will be there. So this kind of piston is there. We are supplying heat energy. When you are supplying heat energy, the gas molecules will absorb the heat energy and they will have more kinetic energy now. They will move here and there more randomly. They will kick up this piston. They will just kick up that piston to a greater extent so that the piston will start moving up, because from here they are pushing up this way. So the volume will increase that way, right? Molecules gain energy. Very good. On increasing the temperature, the molecules kinetic energy will increase, as a whole volume will increase, right? Sir, but even the pressure increases when the temperature is more. Everything is interrelated, but what is my point? My point is not like temperature, volume, what is the relation? Pressure, volume, what is the relation? They are directly proportional or indirectly proportional. That is not something I want to discuss here. I simply want to tell that pressure, volume, temperature, number of moles, all these things are interrelated to each other. If you try to change the temperature, volume may change. If you try to change the pressure, the volume may change. So they are going, this volume is going to be affected by pressure. The volume is also going to be affected by temperature. How many of you are clear with the point that the volume of the gas can be changed by changing the pressure and temperature? How many of you are thinking it is yes? Yes, we can change the volume by changing the pressure and temperature. Clear? Isn't this entropy? Nana, Avyukt, please don't incorporate this kind of words, entropy and all. It will be confusing for other students. Okay? We'll discuss about entropy in thermodynamics chapter, don't worry. But when heat plastic bottle, volume gets decreased. Nana, our point is not plastic bottle. This container is made up of some metal, suppose. It is not. That is melting case, that is different. We have some gas sample. What happens to gas? I'm just talking about. Okay? So my simple point is gas is there inside a metallic container. We are supplying heat energy. Temperature increases, volume increases. The other way, if you try to compress the piston, the volume will decrease, but pressure inside will increase. So simply saying, volume is going to be influenced both by pressure and temperature. Okay, simply saying, what is my simple point here? Volume changes by changing pressure and temperature, right? Sir, take HP gas example. Yes, Nana, very good. HP gas cylinder is there. Okay, gas cylinder is there. If suppose gas cylinder is about to be completed, whatever the gas is there inside, suppose you have consumed everything, very little amount of gas is there. Then what we do usually, you should not try this at home, very risky. Okay, what usually some professionals do, they will put that gas cylinder on top of hot water. They will take a basin. In that basin they will have hot water. On top of the hot water they will place the gas cylinder. Never ever try to do this. Very risky. It is very, very risky. Never ever try to do. Explosion will be there. But what I'm saying is, if a gas cylinder is kept on top of hot water, then what will happen is, whatever the gas inside is there, those gas molecules will absorb the heat energy from the hot water. and their kinetic energy will increase as well as their pressure will also increase. Yes, inside molecule will gain energy. Very good, Nana. Very good, Siva. Yes, correct. So pressure will also increase. Sir, here pressure will increase. Yes, yes, Samistha, it is going to be the case. Samita, yes, you are correct. When energy is absorbed, heat energy is increasing, temperature increasing. Once temperature increasing, pressure will also increase. Okay. Once temperature is increasing, pressure will also increase. This part we will once again discuss in gaseous state chapter, but my simple point, pressure and temperature, if you change, then the volume of the gas will also change. For that reason, now what I will do, I will not change pressure and temperature. I will take a constant pressure and constant temperature. That is called as standard conditions. Standard temperature and pressure. Standard temperature and pressure. What is that standard temperature and pressure? The standard temperature is 273 Kelvin. Can you convert Kelvin into Celsius? Can you convert 273 Kelvin into Celsius? How much it is? 0 Celsius. Yes, 0 degree Celsius. 0 degree Celsius. I hope you know this, right? We know that temperature in degree Celsius, or we can convert Celsius into Kelvin, right? Temperature in degree Celsius is equal to how much? Temperature in Kelvin scale minus 273, right? Or you can say the reverse one, temperature in Celsius scale plus 273. If you do, you will get Kelvin scale temperature. So 0 degree Celsius, 273 Kelvin, right? What about 25 degrees Celsius? 25 degrees Celsius, how much of Kelvin? Can you tell me? In the Celsius scale, you just add 273, you will get the answer. So 25 degrees Celsius plus 273, which is 298 Kelvin, right? Celsius and Kelvin, how to interconvert? Just in the Celsius scale, you add 273, you will get the answer in Kelvin. Okay, now my point is, standard temperature and pressure. What is the standard temperature? 273 Kelvin. And what is the standard pressure? Standard pressure is 1 atm, 1 atmospheric pressure. The standard pressure is 1 atm pressure. Means whatever the pressure we have in the surface of the sea. Like, sir, if pressure increase, volume should decrease. No, sir. If you increase the pressure, volume should decrease. Yes, Samita, you are absolutely correct. If you increase the pressure, volume will decrease. I have discussed pressure volume relation, temperature volume relation, if you remember. Okay, but now I'm not into what is the pressure volume, and what is the temperature volume relation. Simply saying pressure, temperature changes, then volume will change. But for that reason, I will fix the pressure. I will fix the temperature. So that volume should also be fixed. Right? Sir, when should we subtract and when should we add, sir? Kanishka, very simple point, ma. What I am saying is, Celsius temperature is there. To convert it into Kelvin, you simply add 273. But if the reverse is there, Kelvin temperature is there and you want in Celsius, then you might do subtraction, right? If Celsius is there, just add 273, you will get in Kelvin. Pascal. Pressure units, we have several units. Pascal is there. Okay, atmospheric pressure, atm is there, bar is there, torr is there, mm of Hg is there. All those things one by one we will discuss everything. Don't worry about that. But my simple point is, pressure, one of the unit is atm, and the atmosphere wherever we are living now, here the pressure is 1 atm. If you go to higher mountain regions, okay, if you are going to mountains and all, there the atmospheric pressure will be decreasing. Okay, their pressure is low. But wherever we are living on the surface of earth, in the troposphere, lower level of atmosphere, there the pressure is 1 atm. So at that point, at this pressure, 1 atm pressure and 273 Kelvin temperature, what we have observed is 1 mole of any gas. 1 mole of any gas will have a fixed volume, and that volume is 22.4 liter. Very, very important point. This point is very, very important. You please focus. What I'm telling is pressure and temperature if gets changed, then the volume will change. But now I have fixed the pressure and fixed the temperature. What is the pressure I have fixed? Pressure I have fixed 1 atmospheric pressure, and the temperature I have fixed 273 Kelvin. What about the pressure in water? The pressure caused due to water vapors are called what? Vapor pressure. That we will discuss later, Nana. Okay, don't mix up the concepts. Okay, if we boil water, temperature will increase and water will evaporate. That means it will decrease, but how it increases, sir? Now you are talking about liquid water converting into vapor. But I am not at all talking about any liquids. Whatever the discussion is going on, it is everything related to gas. I am not talking about liquids. I am not talking about solids. Everything is about the gases. Okay, so let me discuss this once again. What I am saying is I have the pressure and temperature with me. If pressure temperature changes, then the volume will change. But I will not change pressure and temperature. I will take the pressure and temperature. This pressure and temperature I will take constant. What is that? 1 atm pressure and 273 Kelvin temperature. And this pressure and temperature condition is called as standard condition. At the standard condition, if you take 1 mole of any gas it may be, then the volume is going to be fixed. The volume is going to be fixed, and this volume is called as gram molar volume, and that volume is called as gram molar volume, or simply we can say molar volume. You can skip this gram as well. You can say gram molar volume or molar volume, whatever is convenient to you, you can say. Okay, why it is called molar volume? Because it is the volume of 1 mole of gas. The volume occupied by 1 mole of gas is called molar volume, right? And what is the molar volume? How much is the molar volume at STP condition? This condition is called as STP condition. What is STP? STP means standard temperature and pressure. This STP corresponds to standard temperature and pressure. Yes, please give QR code. I will give the QR code. What I'm saying is STP stands for standard temperature and pressure. And what is the standard temperature? The standard temperature is 273 Kelvin. What is the standard pressure? The standard pressure is 1 atm. If the condition is standard temperature and pressure condition, and at that point of time we will be having the volume of gas to be 22.4 liter if you are taking 1 mole of gas, whatever the gas may be. Okay, let me give pictorial diagram of this. I have in this container I have 1 mole of hydrogen gas. In other container I have 1 mole of helium gas. In the other container I have 1 mole of methane gas. Whatever the gas you can take. If I am taking 1 mole of gas in these containers, and in all of these I am fixing the temperature to be 273 Kelvin. I am fixing the pressure to be 1 atm. What is this pressure and temperature condition? This temperature and pressure condition is called as STP condition. So at STP condition, what is the case? At STP condition, what is going to be the volume in all of these? All of this will be 22.4 liter. Let us say it is not 1 mole, half mole of helium. Then what will be the volume? Half mole of helium. We know that at STP condition, if the condition is STP given, then 1 mole of gas will be 22.4 liter. Then half mole will be how much? 11.2 liter. Very good, very good. You guys are awesome. It is 11.2 liter. In the last case, I am not taking 1 mole. Rather, let us say it is 1/4 mole. 1/4 mole of methane. Then how much will be the volume? It is again half of that, which is 5.6 liter. So 1 mole will be 22.4 liter. Accordingly, you can calculate for half mole, 1/4 mole, or any amount of moles. So whatever the amount is given, for that you can calculate the volume. But it should be mentioned that the condition is STP. If the temperature and pressure changes, then we cannot guess how much is the volume of the gas. Okay, that we will discuss in the upcoming classes, like from ideal gas equation, we have an equation called ideal gas equation from which we can calculate that. But at this point of time, for time being, I can say if STP condition is given, then volume will be 22.4 liter for 1 mole. Is that clear? Yes, 2 mole means 44.8 liter. Mahima, very good, very good. Yes, very good. So on this behalf, now let me tell you, side sir, okay. You want to note it? Yes, please note it. Please note it. सर सुबह क्लास क्यों नहीं थी? मैं बोला ना कि क्लास क्यों नहीं थी. रीजन ये है कि सुबह क्लास रखने से तुम सुबह क्लास करने के बाद सो जाते हो, इसलिए हम आफ्टरनून रखें सो दैट आफ्टर लंच ऑल्सो तुम्हारे पास एनर्जी रहे और कॉलेज आने के बाद तुम फुल एनर्जी के साथ पढ़ सको. यहाँ पे हम हैबिचुएट करा रहे हैं तुम्हें. 1 atm has any value? Sanjana, 1 atm has any value? Very good question. I will discuss what is 1 atm pressure. Okay, I will elaborately explain that part. What is actually 1 atm? What is the meaning of 1 atm? But as of now, you just remember whatever the atmosphere in which we are living, that has a pressure of 1 atm. When you are going to higher altitudes like mountain and all, their pressure will be very less. That's why we do take oxygen cylinders when you go to higher altitudes, right? Okay, very good. Now let me tell you what is Y map and we will conclude today's class. So you see here, what is Y map? What is Y map? So in the center we have number of moles. Number of moles is related to 3 things. What are that? We have moles related to mass, moles related to volume, moles related to number of particles. Okay, you people tell me, if we have mass given in the question, if mass is given mass is there, how to calculate the number of moles? Can you tell me? Given mass is there. I have 24 grams of carbon. Then what is the number of mole? You will say 24 divided by 12. Given mass by molar mass, gram molar mass, right? Gram molecular mass. Very good, very good. So if mass is given, if you divide by, if mass is given, divide by gram atomic mass or gram molecular mass, I can say simply molar mass. Okay, if mass is given, if you divide by molar mass, you will get the number of moles. Similarly, mole is there, how to get mass? If mole is there, how to get the mass? If 1 mole of carbon is 12 gram, 2 mole will be how much? 1 mole is 12 gram, 2 mole 24, right? Just you have to multiply. Mole is there, you multiply the molar mass here. So it is just the opposite. Mass is given. If given mass is there, divided by molar mass, you will get number of moles. Mole is there, multiply with molar mass, you will get mass. Means they are interconvertible to each other, right? The similar way, how to find number of moles when volume is there? I have 44.8 liter of a gas, any gas, I don't know what is that gas, at STP. If I have 44.8 liter, then what is the number of moles of this? Monica, 2 moles, 2. Okay, I can see several answers. It is 2 moles. Very good, very good. So if 44.8 liter is the given volume, so given volume by molar volume, if you do, what is the molar volume? What is the molar volume? The volume of 1 mole of gas. The volume of 1 mole of gas, 22.4. Yes. So if volume is given, divided by 22.4, then you will get number of moles. And from number of moles, how to get the volume? Just multiply instead of division, right? In the case of number of particles, I have 12.04 4 into 10 to the power of 23 sodium atoms. Can you tell me how many moles are there in this? 12.04 into 10 to 23 sodium atoms. How many moles are there? Very good, very good. Several students are saying 2 mole, because we know 6.02 into 10 to the power of 23 is 1 mole, and this is just exactly double of that. So it is 2 mole. So what we can say, whatever the number of atoms are given divided by Avogadro number, if you do in the red, your tricks are insane. Thank you, Nana, thank you. You please focus here. If this is the given number of atoms divided by number of particles. Particles means it can be atom, it can be molecule, it can be anything. So given number of particles is there, divided by, if you do Avogadro's number, which is 6.02 10 to 23, then you will get the number of moles. And from mole, how to convert into number of particles? Just do the reverse. Here division, here it is multiplied with Na. Is it clear? Guys, is it clear? Please give a thumbs up in the chat section so that I can ensure from my side you guys have understood this. Someone is having doubt. Yes, I can see several yes in the chat section. Yes. Sir, can you explain once again? Okay, very simple. What I'm saying is, I have 36 gram of carbon. If 36 gram of carbon is there, what is the number of mole in it? Those who have doubt, please respond. Others, please don't answer. Those who have doubt, you only try to answer this. Yes, 3 mole. Yes, very good, 3 mole. Because we know that 1 mole is 12 gram, 36 gram will be 3 moles. 1 mole is 12 gram, 2 mole will be 24, and 3 mole will be 36. So when 36 gram carbon is there, how to get number of moles out of it? Number of mole is given mass is 36 divided by molar mass is 12. So it is 3 mole, whatever you said. So given mass by molar mass is number of moles, right? So when given mass is there, if you divide by molar mass, you will get the number of moles. That is what my point is. Similarly, if given volume is there, divide by 22.4, you will get the number of moles. If given number of particles is there, like given number of atoms are given here, divide by Avogadro number, you will get the number of moles, right? So what is the conclusion? Whatever is given, it may be mass given, just like 36 gram of carbon here. It may be volume given, just like 44.8 liters of any gas. It may be number of particles given, just like these many atoms of sodium. Whatever the things are given, from that, if you divide molar mass or 22.4 or Avogadro number of particles, you will get the number of moles. What is the use of this Y map? Y map is something like whatever mass or volume or particles given, from that always we have to calculate moles. Okay. So what is the main application of this? Usually they will give number of particles. Then number of particle you have to calculate mole, and from mole you can calculate the mass as well as the volume. Suppose they have given the volume. If they have given volume, from volume we will calculate the mole, and from mole you can go to mass, you can go for the number of particles. So out of 1, 2 and 3 in the Y map, 3 components are there. Out of these 3 components, you have to they will be giving any one of them out of this mass or number of particle or volume. One of them will be given. You need to calculate the number of moles out of it. Then you can go for any other part. Are you getting my point? Applying unitary method is better, or these formula? Ashok, you simply remember. If you remember this formula, we can do better calculations. Unitary method and this formula is not different. This Y map is based on the unitary method itself. That's why I have first discussed the unitary method and I came to this Y map now. So whatever the thing is given in the question, just convert into number of mole, and from mole you can get anything else, whichever is being asked in the question. Okay? Yes, very good, very good. So you please revise all these concepts for today. What I can say is, you please revise all these concepts. Time is not there for next class. Already I have used 5 minutes of time. So please revise all these concepts. Come for the next class and we will discuss sample of questions on this, and I will give the worksheet for you people to solve. Okay, sir, give homework. Okay, I will give, but time is not allowing me as of now. I will share the PDF with you. Okay, through the proper channel I will share the PDF with you people. Chalo, for timing, let me bid by this method. Okay, okay, time is not allowing us. Okay, QR code is also shared with you people. Now you please cover up all the theory portion whichever we have discussed till today. Okay, we'll meet you in the next class. We'll meet you in the next class. Paina ekkada? Ekkada? Okay, okay. Chalo, we'll meet you in the next class. Thank you guys. Have a good day. Chalo, bye bye. Bye.